Number 1. Find the limit of a sum, a difference, and a product. So many functions are combinations of sums, differences, products. Sums being additions, differences being subtractions, products being multiplication. Of a constant function and the identity function. The following properties can be used. So, if you're given the limit is x approaches c of f of x plus g of x, so two things added, you could actually write the limit out twice for each function and then do the math. So, an example here is if we have the limit is x approaches negative 3 of x plus 4, we could go, the limit is x approaches negative 3 of x plus the limit is x approaches negative 3 of 4. We could split them up. Now, is there any issues here with this 3? Can I just plug it in? Is it a negative? Well, yeah, there is some issues, but not in the way I was asking. Issues in my writing, in my computer skills. Computation. Computering. So, if I have a negative 3 there, I can just input it, correct? And when I input it, the limit goes away. So I can get negative 3. And then when it's just of a constant, the answer is just constant, right? Because there's no value to fill in. So it'd be plus 4, and my answer would be 1. And we can go and do that because we can split up the limits. That's the property. But I told you, once you know that property, are we ever going to use that property? No, it's convoluted. It's limit and limit and limit and limit. What I told you is, if your filling in the value doesn't get you a problem, so like a 0 in the denominator, you can just plug it in, correct? So here, I wouldn't ever actually separate it like this, but the property makes you be able to separate it like that. What I would do is, if I plug the negative 3 in, do I have any problems? No. So I can plug the negative 3 right into here. Okay? The moment I plug the negative 3 in or substitute it in, the limit goes away. We agree? Now, is it stupid to do your question out of the question? Yes, it is stupid. You should rewrite it. Please don't go and then start working from the question. That is not actually real now. Stop yourself. So you would go the limit as x approaches negative 3 of x plus 4 equals, and then I just fill it in, negative 3 plus 4, and I get 1. So it results in the exact same answer, correct? So the reason why we can just go right away and fill it in is because of the properties where we can split them up with limits. And splitting it up with limits doesn't change when you learn the problem. Okay? What do you think is going to happen with a subtraction? You're going to subtract. So it's going to be the same thing. So you could rewrite it as the limit as x approaches 4 of 6 minus the limit as x approaches 4 of x. You could split them up. So this would equal 6, and this would be minus 4, and we would get 2. Do we have to show it that way? No. What we can do is we can just rewrite the question. And because there's no issues when I plug the 4 in, I can just plug it in. 6 minus 4, and I get 2. So you don't have to split limit. Okay? But the reason why it works why you can just plug it in is because when you do separate it in a limit, it doesn't really change it. A product. So, if I plug the 3 in right away, would it work? Yes. So I could go the limit as x approaches 3 of x squared, and then I can plug it in. When I plug it in, the limit drops off, so I get 3 squared, which is 9. And I can plug it in so it will work. Why does it work? Because we can use the property of products, and when you have two things multiplied, you can separate them on separate. So x squared is actually the same as x times x. So I could have rewrote it as the limit as x approaches 3 of x times the limit as x approaches 3 of x, which is 3 times 3, which is 9. And you do not have to separate them. But the reason why you don't have to separate them is because this is the product. If you do separate them, it doesn't change it. So, if I plug in negative 5 here, do I have any problems? No, so I'm going to do it. I'm going to work this one right from the question because it doesn't say for the equation. It's just ask the limit is. So you can work off this one. So you go -4 times -5, which is? Okay. This one says the same, says that if you have a coefficient in front, you can take the coefficient and drop it in front of the limit and then just find the limit. So you could take this 2, drop it in front, and then just find the limit of x and x plus 4. But if I plug the 1 in, is there any problem? So can I just plug the 1 in? Yeah. So I can go 2 times 1, and then 1 plus 4. So I get 2 times 5, which is 10. What does this mean? The limit as x approaches 1 of 2x, x plus 4 equals 10. What does that actually mean? What does the limit mean? What it approaches from the left and the right of the graph 2x, x plus 4. So this is a quadratic, because this would be 2x squared plus 4x, or 8x, sorry. 2x squared plus 8x, right? So on the graph of 2x squared plus 8x, when I approach 1, from the left and the right, I'm approaching 10. You also have math knowledge before this. You have been doing math for a while. I don't know if you know this. So you have some information in your brain. This is a quadratic. We agree? 2x squared plus 8x. We know that quadratics are continuous. We agree? Quadratics are continuous. So I know, because I have math in my head from previous years, that from the left and the right it's approaching 10, but because it's a quadratic, what would it actually be at f of 1? No. 10. If from the left and the right it's approaching 10 and it's a continuous function, at 1 it's going to be at 10 as well. Right? In order to prove continuity, the limit from the left and the right and the value have to both be the same, correct? So we know from continuity that limit as x approaches 1 of that must equal f of 1. We know that. So we can use the ruling of continuity, and knowing that this is a quadratic and quadratics are continuous, we know that f of 1 is 10 because of the reasoning of continuity. If this is a continuous function because it's a quadratic, which it is, then we know without even filling it in that f of 1 is 10. Because these have to be the same in order for this graph to be continuous. And because it's quadratic, it's continuous. Every polynomial function is continuous. Linear, quadratic, cubics, quartics are like the w's of the m's, quintics are like crazy squiggly snake thing. I don't know, but all polynomials are continuous. Okay. This one, it wants it from the right. Now some people are like, but there's no greater than sign. Well, that's what I do. Okay, there is one equation. This equation, if I expanded it out, would be 8x minus 4x squared, correct? So it's concave down parabola, is it not? Right? So the limit at 2 from the left, from the right, at the limit, and the value at 2 should all be what? The same. So if it's a continuous function, I can just plug 2 in, even if it's from the right or from the left or at 2, correct? Because this graph is continuous. So this plus sign, it means from the right, but it doesn't change how we do this question. It's continuous. The left and the right at the value will all be the same because it's quadratic. So we can just plug it in. 4 times 2, and then 2 minus 2. So it's 8 times 0. And some people will say, well, now that's a problem. It's 0. We can have a 0 as an answer. We can have a 0 in our numerator. We just can't have a 0 in our denominator. Did I have other tries before this? That's our problem 13. Okay. So here it says to find the limit of piecewise defined functions at numbers where the defining equation changes requires the use of one-sided limits. Majority of the time, you're going to start seeing a repeat. Because what I do is I go over the whole thing in the first lesson, and then I kind of repeat the same thing, so it connects by the third lesson. So here it says, find the limit of x approaches 2 if it exists. Right? So how do we prove that it exists? For both sides, they equal the same thing. Did I ask if it's continuous at all? So I don't even care what it's equal to, right? I just care if the limit exists. So I'm going to go the limit as x approaches 2 from the left. Which function do I use when it's 2 from the left? Top, 3x plus 1. And then I can plug it right in. This is a continuous function, correct? 3x plus 1 is continuous, so from the left, right, value is the same thing. So we're going to get 3 times 2 plus 1, which is 7. Then I have to prove the limit as x approaches 2 from the right. Which one's from the right? The second. 2x, x minus 1. Then I can plug in the 2, so I get 2 times 2, and then 2 minus 1. So I get 4 times 1, which is 4. Row. What's the limit as x approaches 2 of f of x? Does not exist, because from the left it's approaching 7. From the right it's approaching 4. And then there's this gappy thing going on. So the limit at that value doesn't exist. So therefore, the limit as x approaches 2 of f of x does not exist. So we're going to do a sketch. Where do we start? I start at the 2. That's what I do. I start at 2 on all of them. So I've already found the answers to it. So I know on this one on the left, it's at 2 and 7, correct? There's a coordinate at 2 and 7. Is it open or closed? It's open because there's no equal to 7. So at 2 and 7, I have an open dot. Now that equation, the 3x plus 1, works for anything to the left of 2, correct? So now I can fill in any values I want, but they have to be on the left of 2. So I can fill in 1, right? So if I find f of 1, I'm going to get 3 times 1 plus 1, which is 4. So now I have 1 and 4, and it's a closed dot. I'm now drawing all the graph from the left of it, right? What next value could I plug in and get a y value for it? 0. So I can go f of 0. It's going to get filled into the 3x plus 1 equation because that's all the values less than 2. So I get 3 times 0 plus 1, which is 1. So now I'm at 0 and 1. What else can I plug in? Negative 1. 3 times negative 1 plus 1, which is negative 2. And I could keep going, but at this point I have enough points that I think I can attempt to cross it. So that would be the graph on the left of 2, correct? Followed all the x values on the left and we plugged them in and got values. Now we have to do on the right. On the right of 2, what coordinate do we start at first? 2, 4. And is it a closed dot or open dot? It's closed because there's an equal sign on this equation. So 2, 4 is the very first point on that side, and it's closed because it's equal to. Then I need another value. So now I would pick 3. That's it. And I would plug it into this equation. I'd be at 12. So that's 3 and 12. And this one has x-intercepts at 0 and 1, right? So they're going to... So let's just go. Is there any harm in typing it into your calculator to see what it looks like if it's a calculator section? No, there's no harm. You should actually do that to see what this graph looks like, right? And then you know you're only drawing whatever part of that quadratic exists from 2 on. So you can blatantly see here that this limit doesn't exist. You can also tell this function is not continuous. And why is it not continuous? The moment your limit doesn't exist, the graph can't be continuous. Because if the limit doesn't exist, that means from the left and the right, I'm picking up my pen and having to draw, right? So from the left, I'm like, and then from the, and then down here, and then. So if you have to pick your pencil up, it means the limit doesn't exist. It's immediately not continuous. So if the limit doesn't exist, or f of that value doesn't exist, the graph is immediately not continuous because you can't keep drawing straight. Okay? Then here's this one. Now the power. What you can do if there was an equation is you could write it as just the limit itself and then take that answer and raise it to power. But like I said, if you can plug it in, there's no problem, you can just plug it in. Okay? So if I plug the 2 in, am I going to have any issues? No. So I can just go 2 to the power of 5, which is 32. Now what does that mean? That means from the left of 2 and the right of 2, this graph is approaching 32. This one, you would go 2 times 1 minus 3 cubed, which is negative 1 cubed, which is negative 1. So once again, this one, this particular cubic function, when I go from the left of 1 and from the right of 1, they're both approaching negative 1. And because it's a cubic function, I also know that f of 1 is negative 1 as well, because the cubic function is continuous, correct? So the limit will equal up the value of the function. And then give you a variable. All you do is you just plug it in. So it goes in for x, so it's c to the power of n. Okay. If it's a root is just like writing it to the power of a fraction, correct? So it would be the exact same rules as the previous one. You could find the limit and then you could raise it to the power of the code. But if I plug the 4 in, do I have any problems? No. So I just plug it. I'm going to get 4 squared plus 11, which is the cube root of 27, which is this question, example 8, any different than the previous equation? No. One, this is in the radical form, one's in the rational equation, or exponent form, but they mean the same thing. One's radical, one's rational exponent. You're taught that in grade 4. So this is just the square root of x plus 1 cubed, right? Because the 2 would drop as the index. So it's the square root of x plus 1 cubed. Most often, we don't keep them as radicals. We do keep them as radicals in limits, but when we hit derivatives, we'll always make them be fractional exponents. They're easier to do. So if I plug an 8 in, I have no problem, so I'm going to plug the 8 in. Or I could go to limit as x approaches 8 of x plus 1, get the answer to that, and then raise it to the 3 halves. It would be the same. So I get 8 plus 1 to the 3 halves, which is 9 to the 3 halves. And we have to be able to do this mathematically because hackers can test not a calculator. So this 2 can drop in front as the index, right? So this is the same as the square root of 9. I can write the 2 if you feel ready. And then that's to the power of 3, if you want to do this in your head. So it would be 3 cubed, which is actually then they basically say if you have a polynomial, you can just plug in the value. That's what this says. If you have the limit as x approaches c of a polynomial, just plug in c. No problem. That's what I've been saying the whole time, right? And the reason why you can do it is because of the rules we just went over. You can separate them all in limits, and it's going to get you the same values if you did. So, how do I do the limit of this one? Just plug in the 3 in the value. So 4 times 3 squared minus 3 plus 2. So it's going to be 36 minus 3 plus 2. 35. U, B, B, and C. So this one is going to be 7 and then negative 1 to the 5 plus 4 times negative 1 cubed minus 2 times negative 1 squared. This will be negative 7 minus 4. That does nothing. Negative 1 squared minus 2. Okay, negative 13. And then 0 is great. So we get 10 times 0 to the 6 minus 4 times 0 to the 5 minus 8 times 0 plus 5. So even though there's lots of problems before that, they're all like plug-in values. Okay? So I'm going to be nice and give you the rest just to work on those questions. Work on them. They should be easy. Plug in, get in. Okay? And then we're going to finish the rest of that tomorrow. And then we finish the last lesson on Friday, and then you're done with it. Yeah.